Okay, so this video is about friction. Friction is the force of two materials touching or rubbing together. The equation for friction is F equals mu times N. And N stands for the normal force. So basically the normal force is the force that you have on a surface that counteracts the force that is being applied by the object. So that goes along with the, I guess, the equal and opposite reaction, or equal and opposite force. I think that's Newton's third law. So on a flat surface, normal force equals mg. But on an inclined plane, m equals mg cosine theta. And we'll see why in later lessons. So there's two types of friction, essentially. There is static friction, and this is when there's no motion. And then there's kinetic friction. Where am I? Kinetic. And this is when there is motion. So for example, like tires rolling on ground. Static friction will be tires still on ground, right? So one thing that we should know is the direction of friction. The direction of friction is opposite the direction of motion. Motion. I'm just gonna put MOT. So a good example is like cars. It's a little counterintuitive, or at least a lot of people don't really understand, but it's opposite for cars. What the heck? No, I'm sorry. So the direction of friction is opposite the direction of motion. But for cars, it's basically the opposite, because the wheels are actually turning towards the back, and the car is propelling forward. But since the friction has to do with the tires, the friction is actually forward, even though the car is moving forward. So it's a little difficult to understand. But that's why it's said to be opposite, because when people think of motion of car, they think of the car, the direction of the car, but it really has to do with the direction of the tires. So basically, friction does work. Work is basically changing energy, whether it's changing it to heat or whatever. The equation for work is FD cosine theta. And for friction, work turns friction into kinetic energy, which is turned into heat. So that will be useful in the problem that we have. So I had to write it this way just because it was so long. A hockey puck struck by a hockey stick is given an initial speed of 10 meters per second. If the coefficient of friction between the ice and the puck is 0.1, how far will the puck slide? So, to begin this problem, remember we have to know the equation for kinetic energy. So kinetic energy equals 1/2 mv squared. This is just an equation to know. And remember I said that work changes friction into kinetic energy, into heat. So all of these values are equal because energy is conserved, right? So basically, we can set kinetic energy equal to work to find, what are we looking for? We're trying to look for the distance. So kinetic energy, which is 1/2 m. Hope you can see this. 1/2 mv squared equal to work, which is F d. The cosine theta is 0. Cosine of our theta is 0, so it's just FD. So we plug in 1/2. Their mass is our mass given? No, that's what we have. We have to find our mass. And B is 10. Hold on. Our mass, velocity, force. Oh, okay. Yeah, I said it right. 1/2 mv 10 squared equals, okay, so our force would have to be, so we're looking at the force of what, friction. So force is equal to MA, so MA times mu. So friction, the force of friction is equal to the normal force times mu. And in this case, since we're on a flat surface, the normal force is mg and then mu. So it's equal to the mass times 10 times 0.1. So now we'll be able to solve for the distance. So we can cross out our m's. We have 100 divided, we have 100 divided by 2 is 50 divided by, hold on, 100 divided by 2, 50, then we have 10 times 0.1. Anyway, the answer is